Hello student, welcome to today's session. So today we are going to start with our organic series, which would be comprising of entire of your syllabus required for cracking JEE Mains, Advanced and NEET examination. The endeavor of this series is to provide a child a holistic approach to the subject, showing all the interconnections which organic chemistry do have with physical chemistry, inorganic chemistry, biochemistry, along with the authentic source. So I shall be showing it to you the source of content from where I have placed these lectures, and because this is a quite a problematic thing in organic chemistry, lot of experimental data is to be referred with, and generally child feel very confused that which book is to be followed, which data is to be taken from, and which is a more authentic or less authentic source of data. So all that things I will take care of while making these videos, and you would see that in the first lecture itself you would find some interconnections and the authentic sources from where the data is being taken from. And along with it, most importantly, I shall be placing the things in a little intuitive way, unconventional way, so that you feel little enthralled with, because the subject is very interesting, and I will try to place it in a little unconventional way. Hopefully, you would enjoy it, and if in case you like it, do use this hashtag onto the comment section so that I feel myself motivated and would. Would place more videos on a regular basis in regard to this particular series. So, in my style, I used to say it like this, that first I shall be placing every time what is the context of today's session. So, in this first session, we would be targeting ourselves to understand the historical background to the organic chemistry. Although it is not so important, but just to cover up the things in entirety, I have to tell something in regard to the historical background of organic chemistry. So when I talk of a word organic, in good old times, this organic in simple way is referred to as life, or anything pertaining to living things. We generally say it has to be organic. Nowadays also, in modern era also, we in a modern language also, we use a lot of times this word organic growth. This company have had a very good organic growth. Organic in a sense that it is having a natural spontaneous growth, something like that. So the point here is that organic in old times is referred to anything, any compounds which we derive it from the living entities. So the story goes from the time 1675. Nicholas Lamery, he was the person who actually have developed the subject in a way that he suggested that any natural substances can be classified into three categories: mineral substances, plant substances, and animal substances. This belongs to anything which we derive from the animal kingdom, and this obviously from the plant kingdom. Any compound which we tend to get from the animal or plant kingdom is referred to as to be the animal substances or plant substances, and anything which is pertaining coming from the inorganic, from the non-living sources, we generally refer to as mineral substances. And this later on easily got a authentication from the scientist named Lavoisier. This basically is a father of chemistry. He proposed that anything which we are getting from animal or living source, any compound which is derived from living source, is pertaining to organic compounds. So according to him, the classification which the earlier scientist gave was the correct one, that animal and plant kingdom do have compounds which tend to be said as to be the organic entities. But there was a scientist called as Breslus who proposed a vital force theory. He said that all the living entities have something so unique or vital inside them that only allows it to make the compounds of carbon and hydrogen. the compounds of carbon and hydrogen, according to him, has been formed inside the living entities, according to this particular scientist, and he proposed this as to be vital force theory. So to make any compound related to carbon and hydrogen along with some hetero elements, there is vital force required, which is there only in the living entities, according to Breslis. But this vital force theory got discarded because Wohler was the first person who actually have made first organic compound from ammonium cyanate. This ammonium cyanate is being first heated, and this particular compound is being generated, which we call it as a urea. So this is the first, you may say, organic compound which actually being derived from the inorganic entity, and the credit goes to the scientist named Wohler. Now, later on, this is the scientist named Kolbe, in 1845 synthesized acetic acid in the lab, just starting from the carbon and hydrogen. He did a electric discharge to coke, and this resulted in the formation of acetylene. And this acetylene, when treated with mercuric sulfate in the presence of sulfuric acid along with water, this happened to turn into acetaldehyde. This we will do in a later stage, but just to make the things clear. So then on later on oxidation, it gives acetic acid. So acetic acid first time made in the lab, starting from coke and hydrogen, giving a electric discharge, is the credit for this goes to the scientist named Kolbe. So this is a bit of historical background into the discussion that how this thing came into existence. Now, what exactly do we have? The present definition of organic chemistry. What is the modern definition of organic chemistry? So the modern definition of organic chemistry is we generally say organic chemistry is a chemistry which is dealing with carbon and its compounds. This is the one way of saying the things, carbon and its compounds. This is the one way that the whole story roll down or roam around the topic, the element carbon. So this is very important, that anything which is having something in around carbon belongs to the organic part. But more specifically, if I would say, organic chemistry is a chemistry which deals with compounds of carbon and hydrogen, and then they collectively said as hydrocarbons. So chemistry which deals with carbon and hydrogen, in that matter hydrocarbons, we can say it at that way. So those compounds are called as organic compounds, and they do have, along with it, they do may contain heteroatoms also. Now when I say word heteroatom means that other than carbon and hydrogen in a organic entity, other than carbon and hydrogen, if some other element is also there, that also would be said as to be a organic entity. So heteroatoms can be nitrogen, it can be oxygen, fluorine, it can be chlorine, bromine, iodine, it may be phosphorus, sulfur. So these can be said as to be the heteroatom. But the major thing which you would want is carbon and hydrogen. Now here I am placing one important book, a book of organic chemistry which is very popular with the students, is the Book of Solomon. So they categorically say that organic chemistry is a chemistry of compounds that contain element carbon. According to him, anything which is having an element carbon can be said as to be the organic chemistry, and the one which does not contain this element is called as inorganic. Now let us see, because when you go into the Indian domain, that too into the preparation of IIT, JEE or NEET examination, we dig a little more. So let us see, this is one of the authentic book which is writing this way. Then there is another book which is a book very popular in post graduation level, is the book of Claydon, Jonathan Claydon. Very important book. This also is saying that organic chemistry is a chemistry which would deal with the carbon and other elements, and that are being derived from the living sources. So this, in a way, this also is pertaining to the language which we have already said, that the organic compounds are the compounds which would deal with living entities, and majorly with the carbon and its other carbon and hydrogen and other elements. Now here also is a very interesting viewpoint which I found it in this book. Very interesting one. I just wanted to share it with you. Till now, almost in the first video, also in the introductory video, I said it that till now almost 16 million organic compounds are known. Now, according to this particular book, they said that if we say on a conventional level that if we have a carbon compound of containing 30 carbon atoms, if a carbon compound containing 30 carbon atoms is to be uh, is to be made into different structural forms, that almost this much numbers 10 raised to 63 stable compounds can be possible. So this is very interesting, and this much number of carbon atoms are not there in the universe. So here what I'm trying to enthrall you, or what I'm trying to place the fact this way, that it is very very interesting that in the upcoming next 2 3 sessions I will let you know why carbon happens to make so many compounds, and when it is making so many compounds, what is so good about all those compounds. Some of these are can be written only onto the paper because it is not being isolated. Some are isolated. So why the some are isolated, some are stable, why others can't be made? Just like as a matter of fact, if I just would write something like C2, if I would say C2O2, is this compound available? If I just would write with the bonding aspect, this is perfectly fine. In regard to the bonding, it can be there, but it is not existing. So why is it not existing? Or all these matters we will be discussing in the upcoming session. So moving forward, now what exactly do I say when I talk of the compounds of the carbon? Now here is a very interesting viewpoint. As I said, when we talk of our Indian domain, we have to dig little more into the subject. Now, when I talk of carbon monoxide, carbon dioxide, then metal carbonates, metal bicarbonates, oh, these are also containing carbon atoms, isn't it? Metal cyanides, isocyanides, carbides, these all are having carbon in them. Now, the fact of the matter is that all of these, which I just have marked with the yellow marker, is said as to be are said as to be inorganic compounds. These all would classified into the inorganic compounds. Now, what is the viewpoint which you have to take into consideration? So majorly we will be saying organic compounds are the compounds which are having a base of carbon and hydrogen along with some heteroatom. These are must. But when I say carbon dioxide, carbon monoxide, other carbonates, bicarbonates, cyanides, and carbides, these are basically based on the definition of their properties. These there are some important properties related to organic and inorganic, which in a way then defines the subject in that way. What I'm trying to say it here is that just like if I would say carbon suboxide, this is one compound and this is another compound. Would I be saying this as to be organic or inorganic? When I say carbon and oxygen is inorganic, these two are inorganic, can I say this has to be organic or inorganic? That's the point of discussion. No, let me do it for you. So what I'm trying to say is that when you get entangled somewhere that you are not getting the right viewpoint that whether it will be organic and inorganic, then that particular compound is to be seen from the viewpoint of their properties. So there are some unique properties related to organic and some unique properties related to inorganic. Now, if I would say this compound is called as carbon suboxide. This is one of the oxide of carbon, carbon suboxide. Now, when I talk of carbon suboxide, this is being formed by malonic acid. So don't get frightened with this particular molecule. This is malonic acid. Now, if I just would heat it with P2O5 just to make the things easier, this happens to go it like this. Although many of you are not aware of this bonding aspect, but what we have made is this compound. This compound, carbon suboxide, is being derived from malonic acid, and it is having carbon carbon bonds also, carbon carbon bonds along with it. So this that way I will be saying it has to be organic compound. And sometimes it is important to have extra information along with the basic syllabi. That in a way also in thrill at times that we learned some new thing in the session. Now similarly, if you just would heat graphite, now this data you would find in, that is where I always will place some uh, organic inorganic interconnections, because then in a way it makes the holistic approach. So this data you would find in J.D. Lee, a book of inorganic chemistry named as J.D. Lee, very popular with the students preparing for JEE mains, advanced and NEET examination. So if graphite is being heated with nitric acid strongly, you would get this particular molecule. This is benzene 1, 2, 3, 4, 5, 6 hexacarboxylic acid, which in a way is very popular and very popular organic compound, which you would find named as metallic acid. Metallic, or rather I would say, just hold on, I would say M E METL, metallic acid, and this is also called as graphatic acid, or in a way also said as to be uh, graphene oxide. This is one of the compound. Now if this is being strongly heated, what happens is this water molecule goes out. Don't worry about this we will do it in very detail. Here I am just placing the fact that how you have to think of whether it is organic or inorganic, because if you do so, what you would get here is a compound which is very interesting to show here. And this in a way also should enthrall you, that you know, in the basics syllabi you understood something else also in the discussion. So this would be my style, that along with the basic curriculum we will keep on adding some good information along with. So this in a way becomes C12O9. So this compound did not have hydrogen, but it is having carbon-carbon bond. So this I will be saying this has to be organic compound, because it is derived from a organic source. Similarly, if I just would write hydrocarbon CH4, if it is being treated with chlorine in the presence of sunlight, 4 HCl goes out. I just would take out 4 HCl out of it. uh, 4 HCl goes out and you just would get CCl4. So carbon tetrachloride is again a organic, although it did not have hydrogen, but it is being derived from the hydrocarbon. So that in a way would be said as to be the organic entity. So I made my point clear that at times you would get a confusion that which is to be said as to be organic and inorganic. Then if in case you have a confusion, you have to rely on these things, that organic and inorganic compounds have some unique properties in general. That organic compounds are the compounds of carbon and hydrogen along with some heteroatom, and inorganic compounds are composed of all the elements of the periodic table. Organic compounds are generally derived from the living sources. These are derived from non-living things. All of these point of differences are in general terms. Organic compounds can be solid, liquid, and gas, but they do have low melting and boiling point in general. In general, I am saying. And inorganic compounds, majorly they are ionic in nature, so they would have high melting and boiling point. And this is the most important, which you always have to remember, that organic compounds are very less soluble in water. They are very less soluble in water in general. They are more soluble in a non-polar solvent, whereas inorganic compounds are more soluble in water. And last but not the least, these are volatile. Organic compounds generally evaporates easily because of their low melting and boiling point. But inorganic compounds are non-volatile. They generally don't vaporize easily and they are non-combustible. Whereas most of the organic compounds are combustible. As soon as you ignite them, they burn. And lastly, the organic compounds are generally not very good conductor, or they are non-conducting. Aqueous solution of them, the solution of their is not very conducting, but that of inorganic compounds is conducting. And lastly, organic compounds have the uniqueness that they would be existing in large number of ways. They can exist in number of ways because of the fact that they do show catenation. That this particular discussion we will do it in the next session. And inorganic compounds are small in number. So what basically we have derived out here? We generally place carbon compounds into organic or inorganic lists, seeing their properties where we do not get the uh, basic definition. We where we are struggling to address whether it is organic or inorganic, then we have to go for the properties. So this always you have to keep it in your mind. Now the interesting part here is that organic compounds, if I would say it that way, what is so interesting about the carbon from the standpoint of view of inorganic point? Whenever we talk of a carbon from the that carbon containing compounds are organic. But in my thought that I always place it like this, that when you see the carbon in a broader aspect, you would find some very important information in terms of the inorganic aspect also. So I have taken this from the simple data from the NCERT book of 11th class, which you generally have never noticed it that way, or some of you have ever noticed it. That if you take carbon in itself, carbon can be available in many forms. If I talk of the crystalline form of carbon, one of the form is diamond. Now, if you just would see that, if I would say that what is the melting and boiling point of carbon from the point of view of inorganic, if I would say it that way. So just see the melting point of carbon is too high. It is almost around 4100 degrees centigrade. So carbon, if you have as such, in the any form, if you want to melt it, it would not melt. And if you try to boil it out, no boiling point is mentioned in the NCERT, simply because of the fact this boiling point is too large that any container would not hold that container in itself would melt. So this is very interesting to show it here, that if you simply would say the all of these are non-metals, and all of these non-metals, if I start from the boron carbon, so the atomic number 5, 6, 7, 8, 9. So beauty of the thing is, if you mix the two things together, organic with inorganic, here we are talking about carbon and its compound. Carbon when get combined with hydrogen or any of its derivative, its melting and boiling point becomes very low. But carbon itself, when carbon is joining with itself in some way, then its melting and boiling point is very high. So this is almost 4100 degrees centigrade. And same is the case of the boron also. Boron is a non-metal which is also again would have a high melting and boiling point. So around this much degree centigrade, if you just would subtract minus 273 out of it, it would, this is in Kelvin, you would get it in centigrade. So similarly, this value would be around 3650 degrees centigrade. So melting and boiling point of boron and carbon are very high, but as soon as you just move just from the carbon to the nitrogen, oxygen, fluorine, it goes like, it goes a great dip into it. So nitrogen would be existing naturally in form of nitrogen, oxygen is in O2, fluorine is in F2. All of these are gases, and all of these gases have melting and boiling point below minus 200 degrees centigrade. So just see the difference. If you just would see it in a holistic approach, that how interesting is your chemistry. And here at this particular series, we will be pushing ourselves into the organic part, carbon and hydrogen. But overall, if you see it in the broader aspect, the things are very, very interesting. So in the upcoming session, we will be addressing two things, and uh, in the next session, we will be answering two, three things together. Why carbon makes so many compounds? This is very important. Almost 16 million compounds is being said by the book, and we would not be doing that much. But definitely, there are lot many organic compounds. We will be sharing it with you, and why a given. Just let me place just, if I just would write C6H6, all of you might have seen it or learned it in your 9th 10th class. You always say it is a benzene. Generally we show it like this is benzene. Now as a matter of fact, if I just would show you that this C6H6, if I would not place any sort of stereoisomerism into the discussion, I just C6H6 can be written almost in more than 200 ways. 217 structures are possible. Out of these much structures, you generally know this one, that is benzene. So interesting it is, isn't it? If I just show you the chart, this I found somewhere. So these are almost 217 structures which are possible for a C6H6. Now that's a different story. How many of these are isolated? How many of these are actually existing? But the one which is most stable out of all these is referred to as benzene, as a matter of fact. So the things are very, very interesting. As we proceed, as the things open up, you would start loving organic chemistry. So in the next session, we will be answering why carbon makes so many compounds. And second thing, we will be hitting up, we will be trying to address the bonding aspect, first with the elementary aspect, then a little advanced aspect, so that everyone get hold of it. Whosoever is seeing this video from the 9th, 10th or 11th base or 12th base would feel comfortable with. Thanks a lot. Hope you liked it, and we will be meeting in the next session. Thanks very much. Have a nice day. Stay safe.